Hi, my name is Mathieu Muller. I'm a senior software engineer. I work at Autodesk on Gameware Navigation, which is the low-level AI middleware of Autodesk Gameware. I will present today the Navigation Lab, on which I'm the lead. The Navigation Lab is a visible surface of our middleware. If you take an evaluation of navigation, or if you buy the license, you will have something like this, in which you will have the SDK, the solutions, and the tools. So the most important tool is Gameware Navigation Lab. So you can access it from bin and then release Navigation Lab. So you launch it, and that's what you get. So the Navigation Lab is what we call a visual debugger. So it will allow to view intermediate files of generation, target files of generations like nav data, and also receive visual debug data directly from your own game through the navigation SDK. When you will be using Gameware Navigation, this tool will be with you from day one until probably the end of the production. So what it allows you to do, the first thing, the easier one, is just to play with samples like this and see what navigation can do. So like here, avoidance, obstacles, or generation. Here we have generation. It will allow you to browse all the queries you can do on the NavMesh at runtime. So for example, an A star. Could go there. An A star, or ray can go, or triangle from position to retrieve triangle from a given position, and it will allow to visual debug your own game. So for example, if you have coded an elevator in your game, it will look like this, and you will be able to go back in time and select characters, move around, retrieve, like toggle information, toggle the view, turn off the geometry, and retrieve parameters on the selected bots and elements of the world. So I will. This is basically all you will do. The way it's presented, the general philosophy is the viewport in the center. On the bottom here, you have some helpers to put some markers in the world and copy paste position from almost any text which contains 3D positions, measure distances, and on the top here you have the most commonly used functions. So it's coordinate system, if you import geometry in a different code system, connecting to the remote application. So for example, your own game running either on the same machine locally or running in another machine or another platform like Xbox. The camera, so how to control the world camera. Setting up how to render static data in the view here. Here you have a bunch of commands that will be executed either locally, so like for example generation commands. So let's do it live. So like here, if we start with the with a geometry. You can add seed points. We'll see what it is. You can add tag volume. So all these commands happen in the lab, and you can generate. So here we have generated with an nav tag. You have also like remote commands. So if we launch a navigation lab, the lab game. So the lab game is the other tool that we provide, which is not so interesting when you look at it because it's just a console application, but it's just a simple game containing only AI code, no graphics engine, almost no physics, and no animation system. It's just pure AI, and we are you connect this game to navigation, it's just debugged the way it would be debugged in your own game, integrating navigation. And it's the thing it allows is that it can receive commands from the navigation lab. So now we are connected here. You see the frames on the timeline which are growing. Here the timeline is not moving because the number of, or the size of the buffer, of the recorded buffer, is limited. So now we are connected to the lab game, and all these commands here can be sent from all these groups, can be sent to the lab game. So for example, if you want to spawn a bot, you just press bot and you press the spacebar to spawn a bot. So it will just send a command line here. You see like bot, like the command line is a bit long, like game spawn bot with all the parameters, and the game will send back a log message saying that the bot has been added at this given position. And if you want to access the parameters, here they are. You have a pop-up window with all parameters. So here are game parameters, but you could have like specialization parameters, which are the SDK parameters, the one that you will find in the code when you will code yourself the first spawn of your bot in your own game, pathfinder parameters, and so on. So you see here that you have access to almost every components of Gameware Navigation. So just looking at this, you already know what are the classes of the SDK and what are the different settings that can be entered. So here, for example, if you want to create a cylinder obstacle on the code, you will have the same parameters are here as here. So for example, here I will put an obstacle, and you see that if you would have set the parameter integrate in NavMesh to true, you would see that it will cut the NavMesh. So these are all commands that we send to the lab game, which will end up calling SDK functions with these parameters and instantiate or modify SDK elements, parameters, or behaviors. On the left side here, you have the sample, you have the scene. So the scene represents all static data. So here you can see that we find back our static tag volume that we can turn on and off. The seed points that we have added, and the obj file. To toggle things on and off, you can use like to set up the static view. You can just go there. So if you want to hide the geometry, you go in geometry and set hidden. If you want to change the nav data rendering, put it in solid, for example, you can change it here. If you want to hide the generation input, like the tag volume and the seed point, so that you only see what's relevant at runtime, then you can toggle it on and off there. If you want to set up the same thing for the runtime view now, so what you have in your game that has been sent to through the network. It's here on the panel on the left. It's called Visual Debug View. So here you find all the basic elements of Navigation Lab that you found here. But, box obstacle, cylinder obstacle, nav graph, point of interest, and tag volume. So same thing, you can show and hide each thing. So here you have the obstacles that we have spawned and integrated in the NavMesh that are here, and yeah, we have just spawned that for now. So let's just hide the set points and tag volumes. And inside each group, you can toggle on and off things depending on what you have selected and so on. So here you have basically two columns, one for unselected, the unselected view configuration, and the selected element configuration. To select something, you press Ctrl and left click. That will select an element. So if you want, for example, to have the selected element in wireframe, the selected bot in wireframe, you just press here and you will have other characters, other bots which are not in wireframe and this guy in wireframe. Or if you want the opposite, just press the opposite. If you want to hide all unselected, you can press here. If you want to hide the selected but not the unselected, you press there. You have access to a bunch of information about this character. So for example, you could display the life path, which is the path is following right now, the progress on path, the trajectory, the velocity. Let's see it here. I've seen the input velocity and the output velocity computed by navigation. Now, if you want to browse, when you select an element, or if you select anything like in the scene view, you will have its attributes on the right panel. So here we have to show it again, but we have if you select this tag volume here, you will have the brilliant vertices and access all the properties of this. Same thing for seed point, or for the nav data, or for the sector. Same thing also if you select in the view. So if you select a bot, you will have all his attributes on this panel to the right. And these panels, some attributes are read-only, so like status, and some other are editable. So the editable ones correspond exactly to the SDK, again to the API. So if you create a bot, you will have the specialization. You will have to configure the specialization, and for example, if you set up the shape, so if we edit and we set it to 1, because if the nav data have been generated for a character which is 2 meter high, a 1 meter high character can also go on the same places. So let's say 1 meter. You will see that what we do, that we send a new configuration for this bot to the game through the network, that the new configuration is taken into account, and that the visual debugging sends back the new information about the bot. So changing it here or directly on the code would just result the same in terms of visual debugging. You will see the guy becoming smaller. You can also apply it to all. So that's a good way to play around with parameters. So for example, if you want, let's launch the avoidance sample here. So for example, here you see that they are avoiding each other. If you want all characters to avoid each other, to deactivate avoidance to see how it goes, you just can edit and apply to all, and you will see that just the people now are going through each other. And you can go a bit more in the middle and just play around with parameters avoidance parameters and see if you want to enable them to stop or back move or force passage and so on. So it's a great way to learn the capabilities of the API without touching any line of code. And then when you start coding your characters and your obstacles and your tag volumes, you will exactly know what each parameter does. The other thing you want to learn is the query set. So queries are operations that you run on the NavMesh to retrieve a given information. So the queries can be either done locally or remotely. So for example, the A star here, which is finding a path, can be done either in the the navigation lab, or you can also perform directly in the game. So here you see it's directly performed on the game. So if I had an obstacle, you see that the pathfinding is affected. Ray can go, for example, is can I go from one position to another one? And for each query, you have, let's go back to the A star. You have the start position. If you need a destination or a direction, you have the second position. You can choose if you want to use the position A, the marker position A. So to put a marker, you right click and set marker. Or as it said, you can press F1 and F2. So if I want to put position B, I would just press F2. I have to show them because we don't show them. So I would just press F2 somewhere and choose to make the A star from post A to post B. And post A is here, and you could copy paste the position. So for example, if you copy the position here and paste it at post B, then the new position is updated and then go there. And you can paste any kind of text also that you have copied from your code or from the output of your C++ debugger or from an email sent by a colleague. So yeah, and so for every query you have this system, you have the parameters of the query again to play with them. So for example, here if we put the start a bit outside, then you will see that the visual debugging of the query will say that the start is outside, and we'll put this in red because you cannot access it. So like for example, let's put it here. So you cannot, that's where you want it to go and you cannot access it. It's because you have a hooking mode which is do not hook from outside. So if you activate the hook mode from outside, then we will try to find the nearest NavMesh from this position and try to start then the A star from this position. And here you see that that it works. This is quite useful because the navigation mesh is not directly against the wall. It's always at entity radius from the wall to improve performances. And sometimes when you put like spawn places, or if you put a button to activate the place you will want the character to go to activate this button may be outside the NavMesh. So you don't want to care about this, and so you activate the hooking mode, for example. So it's just an example about how to play with the parameters. You can also see what is the result. So here you see the pass cost and the pass distance, and how many advance count was needed to perform it, and the result, which corresponds to the enum in the C++ code when you will perform it. So it's the same for like Ray can go. You see, same kind of parameters. You can also set up the traverse logic. So the traverse logic is something you implement in your game. That's the way this query will behave going through different nav tags. So what is a nav tag? It's a way to color a part of the NavMesh. So nav tag is usually set up with NavMesh using a tag volume. So let's see what it does right now. So there are two ways to do it. So let's just take this game, and so the first one is to generate, put the nav tag at generation. So let's generate, and let's say you want the bridge to be tagged. So you just add a generation tag volume. Here we set up a material, but in reality it's a nav tag. We will see what it is after. Material is just a way to demonstrate in the navigation lab what can be a nav tag, a simple nav tag being just one index of material. So here, oh sorry, set the bridge. So here I will spawn a generation tag volume around the bridge, so that I can code the bridge. And if I generate, you'll see that the bridge has now a different color along this tag volume. So I can hide it. And if I launch an A* query from this position to this position here, and on the can traverse logic, instead of being always true, I would say, this is an example of traverse logic. It's always true. It can traverse if it's equal one of these. So here it can traverse only the empty ones. So here you see that it cannot go through the bridge, but it has to go through the to go around. If now you allow to go through the material, it was material 1, you see that now it can go. So you see what is interface like. It's a lab game material, so it's just a way to demonstrate how nav tag can be used. And you will see that here the actual nav tag, which is just an array of uint. Here we have just visual debug for 6 of them, but you can put any number you want. Here we have put an inside lab game, like we have decided of this way of coding things. Like the first uint is the type of nav tag, so here it's a lab game material, and the second one is the actual index of material. So if you use, for example, the triangle from pose, you will see that here. So let's do it at pose of marker A. You will see that the nav tag is 0, 1. And and here, if we change the marker, then you see that it's an empty nav tag. So yeah, that's the way it is. And most queries, they took a can traverse logic. So like a can go here. So you see that it can go. There is a maximum distance. We can put 40 meters and make it go through post B. Then if you want it to be only true when it's an empty nav tag, then you will see that it stops at the border of the new nav tag. But if you allow it, then it can go through. So the second way to put a nav tag is at runtime. So let's, for example, let's put one here. So same thing, you just go to the nav data, you go to tag volume here, and this actions allows you to configure. So let's put material 2, and then let's spawn a tag volume here. And now you see that it's done at runtime. And that's the power of navigation, is to allow tagging at runtime, because if you have, like, for example, a fire, you can just spawn a nav tag and just change the nav tag through time, depending on where the fire is. And all queries at runtime, they work exactly the same with the nav tag, which has been spawned at generation time. So, for example, if I press here and I go there, then it has to go around here because the traverse logic is just go through empty ones. And yeah, and the same if I put the lab cam, if I allow to go through material 2, then it goes through material 2. And it's a very powerful tool. If you spawn 2 tag volume on top of each other with different material, with a different nav tag, so for example if I put 3 and I put it on top of this, what will happen is that the smallest, we will have a comparison operator on the nav tags, and the smallest one will win. So here, because if we look at triangle from pose here, you see that here in the lab game, and not at pose A, but at cursor pose, here you see that the nav tag is 02 and this one is 03. So if you make a if you compare the two nav tags, the smallest one is a green one, so that's why it has 1. And now if you look at the A star to go there, you see that you are allowed to go through material 2. So we just turn around this. So if you place start here, you can go through. If you go there, you will hook from outside, and so on. So yeah, it's a very there are a lot of creative things to do with tag volume at runtime and tagging at runtime, and also the way you code the traverse logic, because here it's just like return true on can traverse if it's equal to this, but you just can code it the way you want depending on the status of a smart object associated to this nav tag and so on. So let's go through just quickly through the other queries that we have. So Raycast, we have talked a bit about this. So Raycast, Raycast is going through the cursor. So Raycast is sending a ray for a certain distance. Put it a bit smaller. And like here it's like 40 meters, let's put 20, and then you find the collision point, always with a traverse logic and with the output. Triangle from pose, we have used it also a lot. Nearest half edge from border, so it just gives you the nearest edge. Disk expansion is expanding a disk for a certain radius. If it's expand, then the result is disk fits, and if it collides, then we give the collision point. This collision is just saying yes or no if this disk collides. A disk can go is just can a disk travel in straight line between two positions, and when you arrive to this kind of positions here, you have like parallax errors which sometimes make you think that it doesn't work. So we have an auto camera which allows to get rid of the parallax errors. To move the auto camera, you just use the keyboard, like the arrow keys, left, right, and up, down to go in north, south, east, and west. And you use the mouse wheel to go up and down. And for the fly camera, by the way, if you want to move it, it's just like a normal game fly camera. So you move the head with left click and drag the mouse, and to go forward and backward you use the arrow keys of the keyboard or WASD, like in a game. We also have a walk camera. So when you go close to the ground, you can go with any camera to a given position, just double clicking there, or pressing focus if you want to go to a marker post. But like here, we want to go to the ground. So we go to the ground, and then our camera is constrained on the NavMesh. So constrained in altitude by the NavMesh and constrained by the borders of the NavMesh. So here you see that I cannot go straight, and there is not any physics behind this. It's just a simple query on NavMesh that is available also for you if you want to use it in your game for character control. So it's just kind of like can go and finding the collision point and the normal, and then to auto to slide on the border and so on. Every movement of the camera can be speed up by pressing shift, so that you can boost. So also when you want to change the height, like with the mouse wheel, you can also boost with shift and so on. So let's go back to the queries. We have a disk cast, which is the same. You cast a disk for a certain distance and you see if it collides or not. Always with the same traverse logic and different parameters you can try. Segment can go, you throw a can go from one position to another and you see if it collides or not. Same thing for the cast and so on. And there are some like runtime, very runtime oriented queries. So like inside post from outside post is quite useful. So because sometimes a character can be pushed outside the NavMesh, like for example here, if you throw somebody on the here it's inside NavMesh, but like if somebody is thrown on top of these cannons, there is no NavMesh on the top or on the side, but still you want the character to walk back to the NavMesh, so you can just find the nearest position and make him go straight, or if it's more complicated, try different nearest positions from the current position of the character and send some physics Raycast to validate them and then throw him directly on it. And specialized collector is a runtime query, so we run it on the lab game. It will allow to, like if we spawn bots, you will see that it collects it takes advantage of the fact that every element of navigation is specialized in the NavMesh, so it's very quick to retrieve what's around. So you just look at the current position, current triangle on the NavMesh, and then you propagate around, and then you would be able to find what's around. So if I add points of interest, which are just simply specialized point in the NavMesh, you see that we can retrieve them. Same for not projected obstacles and so on. Then and other queries that have sense, like best graph vertex pathfinder query, a sense with navgraph that I will introduce right now. But yeah, and also because of its best graph vertex pathfinder, it will find the best graph vertex, so you have to implement what is the condition for a vertex to be the best one. So there's a query will give you each vertex that it finds from the nearest to and so on, and you will, based on its nav tag, you will decide if it's a good one, you think it's a good one or not. So this query requires a specific implementation. Let's show you also, like I've showed you, dynamic NavMesh, so tagging, and also if you put a tag volume which is exclusive here, it does not tag, but it's just cut the NavMesh, and so it's very flexible. I gave you example. And now the second thing interesting you want to do with navigation is probably to make not connected places, connect not connected places. So for example, if you want to put a ladder from here to there, no NavMesh has been generated for that, so we add dynamic nav graph. So you just add this at runtime, and then if you take this bud here, you can right click and set its destination, and like, okay, let's take him back here closer, and now if you take the destination on the top, it will just use this graph. And so it's just like an extension of the navigation mesh on which you can path find. And then how you will go through that, it's called the path following framework. So that's how you will control. So let's go back in time and see what happened for this guy here when he decided to use it. So you use the visual debug view, go to the bot, and you will display its live path. So what you see is path following framework is based on live path. So what you see here is that this guy has decided to take a path there, and you see that there are path events on the path, which inform you whatever the path is, what's gonna be the next event. So what is gonna change on your path? What is the next thing happening on your path? So here, in the path following framework, you will be able to know that the next event is the beginning of a graph, and that the next event is the end of a graph, and then that and you will be able to query the nav tag on this graph. So when you will approach it, then you will decide what to do with it. So in the basic implementation, if you have not implemented anything, when we arrive to a graph event, we just have to go to, when we are close enough to the event, we just target in straight line the next the end of the graph, the next node of the graph, and then we give back the control. We just go straight to then we just follow the NavMesh as before. And so when you want to implement a special move on this, so for example, if it would be a jump or if it would be a ladder, all you will need to do is just to add some systems that will look at what is happening on the graph, on your live path, and react to that. So most of the time, the object responsible of this is a smart object, which will decide for you what to do on top of this, especially if a lot of people have to go through that. You can also, that could be also the responsibility of your character if it's just about targeting a special animation. So let's go back to the live. And here, so here you see that the game was still running on the background. Here it's still running. So when you press connect, we will just connect back to it. So here we can again move the guy around. I will show you some examples of smart objects. So here on the sample browser, you can see how, like for example, to manage a controllable door. So here you see the path following framework in action. So here the door is a nav tag, and the path following framework is exactly the same if it's a graph or if it's a nav tag. When you look at the path, you will see events, and it will just give you what is a nav tag between two events. So it's the same a nav graph or a nav graph or tag volume. It's the same. Everything is just about events and nav tags. So here, what it does when it approaches, we see that, like the lab game, the way we have implemented it in the lab game on top of the SDK is we detect the next event, we look at the next nav tag, we see that the nav tag, if we use triangle from pose in the query here, if we look, the nav tag is 100 here on the bottom right here. So 100 for our lab game, for our own implementation, but you do whatever you want. is is a type of the nav tag, so it says that it's a smart object, and 0 it's because it's a type of the smart object, so it's a door. 0 is door, and the last 0 it means that it's a first door because there is only one door. So when it's approaching, it knows that the next event is going to be a change of nav tag, and the change of nav tag will be a door coming, and that this door is the first door. So then it will ask the door what it should do. So since you are far enough, it's you just continue the way you would do if nothing would happen. And then when it's getting close, then you ask the SDK the smart object will tell the SDK to not control the bot anymore. So then the visual debug will inform you that it has taken that into account because the bot will be blue, meaning that the control is managed by somebody else, here the smart object of the door. And then the status of the guy, which is rendered through visual debugging. Here you have a custom visual debug for lab game with the smart object status. So if I turn it off and on, so it's like completely custom for your own smart object or behavior. It can be the same. You can send visual debug proper to a given bot with a special name and so on. It's like one line of code to do that, and then you will just manage it. And then since the door is closed, like you have access your game object corresponding to the door using the index of the door, and since it is closed, the smart object decide to guide the bot until the key, the unlocker. So when you arrive there and it's close enough, it unlocks the door, then the door opens, then you wait there, and when the door is open, now the smart object just give back the responsibility of going through navigating in the world to navigation, because now it's exactly as if there were no door. So just give back the control and then the guy pass on through. So we have a bunch of examples of smart objects, but they are all the same in the end. It's all about looking at the next nav tag, at the next pass event, and looking at the next nav tag, and then finding your game object which corresponds to this nav tag and asking him what he should do. If you want to code special animation depending on the type of the ground, you will do exactly the same, but probably don't need a smart object. Your character will just decide on whatever nav tag is on to trigger a new animation. Here a jump. So a jump is a nav graph. You find what is the next event and what is the next nav tag. You see that the nav tag of this graph is of type jump, so you just follow a trajectory, or you could have trigger a jump pushing the jump button on your game controller. You can do whatever you want. And here, like jumping over a graph or jumping over a nav tag on the ground, so on the tag volume, it's just exactly the same code. So you just arrive, you know that the nav tag is different, and you compute a trajectory there. So yeah, it's pretty powerful. A ladder, again, is the same, just about how you will control your character going through the world. And it's all dynamic, so you can just add everything you want at runtime. You have a vault. Again, here it's jumping over a vault. It's the same as it's between a door and a jump, so just like a jump. And yeah, so that's it for smart objects and nav tags and queries. We have gone through, I think, almost everything that the navigation lab can do. Another thing quite useful when you visual debug, so you know how to you know which parameter it is, you know what query you use and so on, but sometimes when you get a bit further in your game, you can have some performances problems. So you have two tools for that: the visual debugging of performances, so the lab game, like the SDK, and also your own statistics can be sent as visual debug data. So here, like the lab game will be just like you sending profiling information, and all these are sent all the time by navigation. I mean, not every frame, but like most of them are sent every frame. But it's when you integrate navigation in your game, you will have this directly. You don't need to add any lines of code, and you know what are the performances of navigation and what is the impact of visual debugging, because when you will be shipping your game, it will be deactivated. So how much time is lost into that, and then you can find back where performances are gone. And one big performance issue is usually around A star and dynamic NavMesh, because these are quite expensive operations compared to just can-go or moving along a path and so on. So what we have is a query queue system, which is also debugged. So what we do is that all the queries that you use at runtime, you don't execute them directly. You can execute them directly, but you can also push them in query queues. So you just at the beginning of your game, you just create as many query queues you want. You can have an array of query queue processed in world update, and other arrays are processed out of world update. For example, if you want to use multi-threading, so you can have queries running on another thread, and then you add query queues on each one. So for example, here in the lab game, we decided to have a main thread default query. So like every query that you use that don't cost too much, we put them here, we push them here. Then we have one dedicated to dynamic NavMesh and one to pathfinding queries. And for each query queue, you set up a budget that we will respect. So if you put a 1 millisecond budget, we will we will treat queries until we have used all this budget, and then we will stop until next frame. You set up also a memory size for it, and then you have some visual debugging information about it. So here, for example, the most interesting is the Pathfinder, because the A star by itself, just one A star, can cost a lot of time to compute. It can be more than 1 millisecond. So what we do is something called time slicing. So we would cut the A star computation so that we can continue it the next frame with the given budget and stop when the A star is finished. So if we have a big map like this one, let's go to large crowd example, and if you have like a village like here, there is 1000 bots around. You will see in orange that the bots are orange are the bots who are computing an A star. And if you look at the visual debugging of the Pathfinder, you will see that there are always about 500 queries on the queue, because the paths are not long, and with a 1 millisecond budget on this map here and on this PC, on this laptop, the bots are arriving too quickly to their destination, and too many bots are asking for a pass at the same time. So what we do is that if you change the budget, now let's put 2 milliseconds, you will see that now the queries are popped out, because we have enough time with 2 milliseconds per frame to treat most of the queries directly fast enough before the next bot arrives at his destination. And you see that now most of them are yellow. So yeah, that's about it for this presentation today of the Navigation Lab. Have a good day, evening, night.